Okay. All right, very good. So we want to look at limits of a function in more details. First, sometimes, as you can see in these pictures, we can tell the limit of a function by looking at the graph of the function. So in these three examples that you see here in this picture, there are three functions, and we want to find the limit at the point x equal to 2. So when x equal to 2. So the first function is f of x equal to, on the top you have x squared minus 4, on the bottom you have x minus 2. As you can see from the graph, the function is not defined at x equal to 2, and that's why you see a hole. So at x equal to 2, there is a hole on the graph. That means the function is not defined. But the limit exists anyway, because as you see, the value of the function as x approaches to the point 2, so here is the point x equal to 2 on the x-axis. When x approaches this point, either from right or from left, the value of the function approaches what? So the y values approach to what point on the y-axis? Can you tell me?
4.
4. So the limit of this function when x goes to 2 is 4. So for this function, the limit of f of x as x goes to 2 is 4. However, if you look at the second graph, you see there is a jump. If x approach, so the second graph is g of x equal to, there is a fraction, the top is absolute value of x minus 2, the bottom is x minus 2. When x goes to 2 from the right-hand side, so here is the point x equal to 2. When you approach this point from the right-hand side, that means when x is greater than 2, the value is 1. But if you approach this point from the left-hand side, the value is negative 1. So for this function, and here, when we say that, we say x, the right limit is when x approach to 2 from the right-hand side. So the right limit, and we write like this, limit of this function g of x as x approaches to 2 from the right-hand side. And for this, we use this symbol 2 plus. So 2 plus means x approaches 2 from the right-hand side. And the reason we use 2 plus, that means x greater than 2. So because if x greater than 2 means on the right-hand side. So the right-hand side limit is 1, as you see in this picture.
Wait, isn't that 1.5? Wait, oh, never mind.
It's 1. While when x goes to 1 from the left-hand side, like this, from the left-hand side, so limit of g of x x goes to 2 from the left, and for that we use the symbol 2 minus. So 2 minus means less than 2. So x goes to 2 from left-hand side is equal to -1. So as you see here, the right-hand side limit is different from the left side limit. And in this case, we say that the limit doesn't exist. The limit doesn't exist. But the right side and left side limits exist, but they are not equal. So the limit in general doesn't exist. Although the right and left limit, each of them exist, but they are not equal. And the third picture, as x goes to 2, the function goes to infinity. So for this function h, the limit of h of x as x goes to 2, either from the right-hand side, so 2 plus is plus infinity, and also 2 minus is also plus infinity. So the limit of h when x goes to 2, either from right or left, is plus infinity. Okay. And here is the table that we discussed last time. So sometimes you can use a table to find the limit. So on one column, you put the values of x, and the other column is the put f of x values and y values. A good example for creating a table so that help us find the limit is this. Find the limit of sine x over x when x goes to 0. So compute the limit of sine x over x as x goes to 0. As you can see, because sine of 0 is 0. So this is a type of 0 over 0 limit. It's an indeterminate form. It's 0 over 0 because sine of 0 is 0. So we cannot tell the limit by just using algebra. So one way is to make this table. So I want you to do it now. Use your calculator. So for example, let the value of x be 0.1, 0.01. So make this table with these values for x. 0.1, 0.01, 0.001, and so on. And then compute sine x over x. Sine x over x. So for example, sine of 0.1 divided by 0.1. But when you use your calculators, you should be careful about what you use for angles. Is it radians or degrees? So use radians. When you use your calculator, use radians. Not degrees. So based on these values, these numbers, we can guess that this limit is equal to what?
1.
is equal to 1. Maybe later I show you another proof using like geometry of triangles, why this limit is 1. But for now, we just accept this as a fact, that the limit of sine x over x when x goes to 0 is 1. This is very important. I'll write it here again. This is one important result that we obtain. So limit of sine x over x, x goes to 0 is 1. Here is another table for square root x minus 2 over x minus 4. Again, we can do this with other methods. I told you, for example, by multiplying by conjugate. We will do it later, don't worry. But if you use this table, you can see that the value is 0.25 or 1 over 4. So this limit is basically equal to 1 over 4. Just by looking at the table, because if you see the values on the table, you see they approach 0.25. These numbers, they approach 0.25. So on the right-hand side, these numbers approach x equal to 4 from the right-hand side. So on the left side here, these numbers approach x equal to 4 from the left side, because these are less than 4, right? So see, these numbers here, these numbers are less than 4, but these numbers are greater than 4. So you have left limit and right limit. But anyway, so for each of them, the limit approach 0.25. So this limit is 1 over 4 or 0.25. So here is important point. If you want to use the graph, you can use the graph to find the limit. For example, in this picture, so what is the limit of this function g when x goes to minus 1? So when x approaches minus 1 is here. So what is the limit of this function when x approaches minus 1? Limit of g is 3, exactly. So limit of g of x, by looking at the graph, you can see that the limit of g of x as x approaches minus 1 equal to 3. However, the value of the function at minus 1, g of minus 1 is equal to g of minus 1 is equal to, look at here,
4.
Is equal to 4. So the limit is not necessarily equal to the value of the function. So if the limit equals the value, we say that the function is continuous. Later, I will repeat this again. So if the limit is equal to the value of the function, we say that the function is continuous.
What if the limit doesn't equal to the value of the function?
We say that the function is discontinuous or is not continuous. Here another example. So the function, even it's not defined at x equal to 2, but its limit exists when x approaches to 2. And the limit is equal to what, based on this picture? Limit of h of x as x approaches to 2 is equal to, so the value of the function, the values of h as x approaches to 2, they approach to minus 1, because it's negative. Okay? Okay, and we have, so two important rules that we have. The function f of x equal to x and the constant function. For the function f of x equal to x, its limit at any point exists as, and it's equal to the x exactly. So limit of x, x goes to a is a. So this is the first important rules of limit. The function f of x equal to x. So limit of x when x goes to a is a. For example, limit of x when x goes to 10 is equal to 10. For the constant function, so constant function is a function whose values are constant. For example, is something like this, is a horizontal line. So let me draw a graph of a constant function. For example, this y equal to 2. This is a constant function. So its limit always exists and is equal to 2. No matter x approaches what point, the limit is always 2. So limit of c, the function constant c, when x goes to a is c. Now, another example, can you use a table to see whether this limit exists or not? So on the top, you have absolute value of x squared minus 4. On the bottom, you have x minus 2. Can you just use a table to see that this limit exists or not? X goes to 2. So the limit of absolute value of x squared minus 4 over x minus 2, x goes to 2. By using a table, for example, here I make a table. This is x. Do it. So the point that you can use is, for example, 2.1, 2.01, 2.001. So let us compute. So if you make a table, you can see that the value of this limit, so for different values of x, like 2.1, 2.01, if you compute this fraction, you will see that the value approach. You don't see my? Yeah, it's the same thing. So you can see that the value approach 4, right? So let me use another way to show that this limit is equal to 4 using algebra. So what is the limit? So let me go to a new page. So I want to compute this limit of absolute value of x squared minus 4 divided by x minus 2. X goes to 2. So here, because we have absolute value, we should consider two cases: when x greater than 2 and when x less than 2. So that means we have to compute right limit and the left limit separately. So first, let me compute the right limit. So right limit means x goes to 2 plus. And what it means is it is actually x greater than 2. Okay. Now, if x is greater than 2, then x squared minus 4 is greater than 0, right? So that means the absolute value inside the absolute value is positive. So absolute value of x squared minus 4 is just equal to x squared minus 4. So for the right limit, because x is greater than 2, the limit of x goes to 2 plus of absolute value of x minus 4 over x minus 2 is just equal to the limit of x squared minus 4 over x minus 2, x goes to 2 plus. And this is equal to, on the top, x squared minus 4, I can write it as x minus 2 times x plus 2. And you see, you can cross out x minus 2 and x minus 2. So x minus 2 is gone. So that means you have limit of x plus 2, x goes to 2 plus, and this is equal to 4. But this is the right limit. What happens if we compute the left limit? Let's do it. So for computing the left limit, or the left side limit, so x goes to 2 minus. That means basically x less than 2. So if x is less than 2, or let's say if x is something between 0 and 2, and positive, still positive, but less than 2, then x squared minus 4 is negative. So absolute value of x squared minus 4 is equal to minus x squared minus 4. So this limit of absolute value of x squared minus 4 over x plus 2, x goes to 2 minus, is equal to minus x squared minus 4 over x plus 2. And this is equal to the limit of x goes to 2 minus. So again, on the top, you have x minus 2 times x plus 2. The only difference is that you have an extra negative sign here, divided by x plus 2. So here, x plus 2 again is gone. Then you have x minus. Why I put x plus 2 is x minus 2. Sorry, forgive me, it's x minus 2. X minus 2, x minus 2. And this is x minus 2. Yeah, on the denominator we have x minus 2. Anyway, so again here x minus 2 and x minus 2 is gone. So at the end we have the minus limit of minus x plus 2, x goes to 2, 2 minus. The 2 minus means x approaches 2 from the left-hand side. So it doesn't matter. X plus 2 is equal to 4 again. But here you have minus 4 is minus sign, so it's minus 4. You see the left limit is minus 4, the right limit is plus 4. So the right and left limits are not equal, as you see. So we say that in this case, we say that the limit doesn't exist, although the right and left limit exist. Okay. Now let's go back to the topic of using graphs. You see, here is another good example. You have a function f of x that is defined for x less than 2 be equal to x plus 1, and f of x is equal to x squared minus 4 if x is greater than or equal to 2. So, and here is the graph of f. So here, as you see, we want to find the limit when x goes to 2. This is the point 2. So if x goes to 2 from the right-hand side, the limit would be equal to would be 0.
Yeah.
But if you approach 2 from the left side, so the limit of f of x, x goes to 2 from the left side is equal to, no, it's not 1, is 3. So the limit of x goes to 2 plus is 0, 2 minus is 3. So again, left side and right side limits are not equal. So the limit, we say that the limit doesn't exist. And we did this question ourselves. So we saw that this limit on the top is minus 4, the left side limit, the right side limit is plus 4. And be careful, it doesn't mean that the right-hand side and left-hand side limits are always negative of each other. No, this is coincidental. This is here is a coincidence, but it's not always the case. For example, in this example, right limit is 0 and left limit is 3. Okay. Okay, infinite limits. So sometimes in many examples, and the best example of infinite limit is what just one over x. Let me draw the graph of 1 over x for you so that you can see. So 1 over x, you see, when x goes to 0 from the right-hand side, 1 over x goes to plus infinity. So when you approach x equal to 0 from the right-hand side, 1 over x goes to plus infinity. And when you approach x 0 from the left side, you see 1 over x goes to minus infinity. So the limit of 1 over x when x goes to 0 minus is minus infinity, while the limit of 1 over x as x goes to 0 plus is plus infinity. So then we say that the limit does not exist. Here again is the same graph. So here it goes to plus infinity, here minus. So here is a good example. What you can say, or what we can say about this function 1 over x minus a to the power n. When x approaches a. So what is the limit of 1 over x minus a to the power n when x goes to a from the right-hand side, a positive? This is equal to always, and n is a positive integer. So here n is a positive integer. So this limit 1 over x minus a to the power n, like 2 to the power 2 to the power 3. So the right limit is always equal to, so look, on the denominator, x is greater than a, right? So you have a small number, but it is positive. So on the denominator, you have 0 plus. By 0 plus, I mean a number very close to 0, but positive. So what is 1 over 0 plus? 1 over 0 is not 0, like a very small number. What is 1 over, we discussed this. We just talked about this, like here. See? 1 over 0 plus is plus infinity. For example, what is 1 over 1,000? Let me write it here.
1 over 1,000.
1 over this. 1,000. But this guy is a very small number, right? But when you compute the limit of 1 over x, then it becomes very large. Basically, when you flip it, so 1 over like 1 million is 1 million, right? So now what is 1 over 0 plus then? 1 over 0 plus is positive infinity. is infinity. It's very large. No matter what n is, so the right limit is always positive infinity. What about the left limit? X goes to a minus. Let me write it with another color. So limit of 1 over x minus a to the power n is 1 over 0 minus is equal to, oh, here, oh, by the way, this is, no, it's not 0 minus, my bad. So it's basically 1 over 0 minus to the power n. N is a positive integer. Here, there are two cases. It's important that n is even or odd. Because if you have an even number, even power, like a square to the power 4, it takes negative number to positive number, right? Even power. But odd power doesn't change the sign. You agree? So for n equal to even, so if n is even, this would be 1 over 0 plus, which is equal to plus infinity. But for n odd, it would be 1 over 0 minus, which is equal to minus. Okay, so limit of 1 over x minus a to the power n, when x goes to a minus is equal to plus infinity if n is even, and equals minus infinity if n is odd. That so here in this picture is an example for n even, the right picture. You see, when n is even, the right and the left limits both equal to infinity, plus infinity. This is plus infinity. So the right limit and left limit are both plus infinity. But for n, an odd number, right limit is plus infinity, while the left limit is minus infinity. Can you see that? This is plus infinity and this is minus. So here is an example. N is odd in this, the first picture. The second picture, n is even. And here is the summary. So if n is even, the limit of 1 over x minus a to the power n when x goes to a is plus infinity. So right and left limit are equal. But if n is odd, the right limit is plus infinity, while the left limit is minus infinity. And here, another important definition. We say that x equal to a is a vertical asymptote. You should know this. Definition of a vertical asymptote. What is a vertical asymptote? x equal to a is a vertical asymptote, x equal to a, this, x equal to a, if the limit of f of x, either x goes to a minus or a plus, is equal to infinity. So either plus or minus infinity, doesn't matter. So the right or left limit, if it is infinity, then we say that x equal to a is a vertical asymptote. So for example, in the top pictures, you see x equal to a is an asymptote, vertical asymptote. In the first example, 1 over x, what is the vertical asymptote for 1 over x?
X.
X equal to 0. X equal to 0 is the vertical asymptote. What about 1 over x squared? What is the vertical asymptote? 1 over x squared.
0.
Again, 0. So x equal to 0 is a vertical asymptote. Okay. So for example, for this function, x equal to minus 3 is a vertical asymptote. X equal to minus 3. For this function, x equal to 2 is the vertical asymptote. X equal to 2 is the vertical asymptote. So now I want you, without looking at the solution, just by looking at this function, find these limits. So for example, what is the limit of f of x? This is the graph of f of x. When x goes to minus 2 minus. Minus 2 minus means the left limit at minus 2. When x goes to minus 2 from the left-hand side. This is minus 2. What is the limit? When x goes to minus 2.
From which side?
Actually, for minus 2 doesn't matter, either from right or left, because they are equal.
3.
3. So x goes to minus 2, either from the left or the right, the limit is 3. So we can say that the limit when x goes to minus 2 is equal to 3 in general, because left and right limits are equal. So what is f of minus 2? F of minus 2 does not exist. Does not exist. So function is not defined at minus 2. So f of minus 2 does not exist. So I just put D and E. Now, let's look at the point x equal to 1. X equal to 1, this point. What is the right limit when x goes to 1?
3.
3. So x goes to 1 plus. That's right, it's 3. So x goes to 1 plus is 3. What is the left limit? That's right, this is 6. X goes to 1 minus is 6. So limit of f of x when x goes to 1 does not exist. This limit, D and E. What is f of 1? f of 1 is again 6. Now let's look at the point x equals to 3. This point, 3. What is right limit x goes to 3? Or left? Because they're equal actually. Negative infinity, very good. So the left, yes, both are negative infinity. So we say that the limit of f of x, x goes to 3 is negative infinity. But f of 3 does not exist. So the limit when x goes to 3 is negative infinity. Yeah.
You know, for previous, for the f of -2.
Go to chapter 2.2 of the textbook. It's on the website. Go to the chapter 2.2 on the website, limits and continuity. If you go to website, calculus? No, it's Benson. You have access to the website? Give me a second. Okay, so if you go to the website of the course, then go and open chapter 2.2, limits and continuity, chapter 2.2. And go to page 156. So go to page 156. Do this question, 46. (46, 47, 48, 49).
46, 47, 48, 49.
On the page 156. And also 59, 60, 61, 62, 63, 64 on the next page, 157. So this question's on 157 and this question's on 156. So for this question on 156, you have to use this graph on the top. For 156, you have to use this graph. For 157, you need to use this graph. 157. Yeah, on the top of the page 157, you see? And when you do this, then when you do that, do 50, 78, 79, and 80. 78, 79, and 80. On page 158.